not very consistent, but is our budget cut intro. So we're given a kind of PDF and it's continuous. This kind of long function here, which represents the height in inches of some random ECE students. And we're asked for 3 parts, which we're supposed to sketch in this given range. Find the probability that an engineering student, or random one, is less than 68 inches, or 5 feet 8 inches, and then explain why this model is a good or bad model. So first, to sketch, well, since presumably you don't have a calculator here, it does good to analyze this function here, and we quickly realize that this is the sum of 2 quote-unquote Gaussians, and we can kind of sketch based off of that. So since we're sketching from 65 to 75, we note that there's one peak, one Gaussian. We can graph these individually and then take the summation of these. So at 65 there's Gaussian and is scaled at 1/5, but because it's actually the height of a Gaussian, or normalized Gaussian, is 1/2, the height would actually be somewhat closer to 0.1. And then at 75, or at 70, we have another one. And then this one has a height of 0.2. And then you can just, kind of sum it by, well, this line is the same. And then take it like that. So that's a very crude sketch of what it looks like. And then here's the more interesting part. We asked for the probability that x is less than 68. So we can just brute force this by doing calculus. We write the entire expression inside, and then you can get the answer. Or we can kind of use a nice property, which is that, well, first of all, we express the sum of our PDF as 2 conditionals. So there's a probability m, and then times the probability w, times x given w of x. So later on we will show you what these m and w's mean, but we know that theta for both is 2, and then the phi for x given m is 70, whereas, not the phi, the mu, the x given w is 65. So we can use this kind of nice property that the CDF is still the probabilities of this conditional, and then we can just use the phi function here and normalize it accordingly. And then this turns out the P of M and P of W, of course, just 0.2 and 0.5 respectively. Let's see, can you see that? Yes. And then this would also, we can just plug in 68 into this CDF right here. And it turns out that the W and the M is just a model for men and women, so it turns out that you can actually model it appropriately this way.